Alright, so here we are. Here's our little chart. And this chart will hopefully help us understand what is a limit. So when we evaluated this function at 2, we got indeterminate. We didn't get a value. But notice what happens as we get closer and closer and closer to 2 without actually ever getting to 2. So you have to imagine I'm starting on each side of this function, and little by little I'm getting closer and closer to this 2. And here I got 1.999, 2.001. And what we have to do is we have to look at this and observe, well, are we approaching some number? And you can keep on thinking about it, well, what if I put in 1.99999? What if I put in 2.00001? And so forth. But in this case, I don't think we have to do that because we see that this number is getting closer and closer and closer to 1, and over here the number is getting closer and closer and closer to 1, so we seem to be approaching 1. Let's draw this graph. Let's draw a graph of this. Now the graph of this here's 1, 2, 3. So here's a graph of the function. And so this little hole right there, that's the indeterminate. And we'll talk about these rational functions again later in the year, although we did graph rational functions back in pre-calculus. But if you remember, if you do have an indeterminate or undefined, or you're dividing by 0, there's only 2 ways to represent that through a graph, and one is through a hole, one is through a vertical asymptote. So we have this hole here. And so the question becomes, as I get closer and closer, and so as I'm coming from 2 on both sides of the x-axis, and I'm getting closer and closer and closer and closer and closer and closer to 2, what am I approaching? Well, we are approaching this value right here, 1. And that's the concept of a limit. As x approaches 2, f of x gets arbitrarily close to 1. Okay? And so when we are looking at limits, and this is an important concept, we are not worried about what's happening at x equals 2. If we want to know what's happening at x equals 2, we would evaluate it at x equals 2. The concept of a limit is we are worried about what's happening around x equals 2. What happens as we are approaching 2 from both sides of our function. And if we approach a common number, then that is our limit. So watch how we write this out. Okay, so this is new notation, of course. There's 2 ways we could do this. We could say, okay, that LIM means the limit. As x approaches 2 of f of x equals 1. So this is saying that the limit as x approaches 2 of the function f of x equals 1. Now we could also write it this way. We could write the limit as x approaches 2 of x squared minus 3x plus 2 all over x minus 2. This equals 1. It's a lot of time. In this case, we were given the equation and they labeled it f of x, so we could just put in f of x, or you can just put the equation. So there's a quick introduction to what is a limit, and again, the idea is we're not worried about what's happening at the value. What we're worried about is what's happening as we approach the value. Okay, so let's write that out with a little, we'll put in an informal definition. So, actually, I think we still have a little room on this. When we look at limits, we do not consider the value, oops, that's supposed to be of f of x at x equals some x of naught. So in the example up here, that would be 2. We only consider the value of f of x as x approaches x of naught. Okay, so I just decided that that was important enough that we just needed to write that down. We're not worried about what's happening at 2. We're only worried about what's happening as we approach 2. Okay, so let's get our definition of a limit. In this case, we're only going to look at the informal definition of a limit. Actual definition of a limit is one of those rather complicated concepts, and it's really difficult. I really don't teach it anymore. If you do take calculus again in either a math or engineering curriculum, you will get it. It's not super hard, and usually in those classes it's not a significant part of the class. That's one reason I'm kind of skipping it. But it is challenging, so I've kind of decided over time that it's not really going to be a part of this calculus class. But let's look at the informal definition. And so we have a little graph here to kind of help us visualize it. And we have some function. There's a function, f of x. And then here is some x naught. And then this is L. Alright, so let f of x be defined on an open interval about x of naught, except possibly at x of naught itself, okay, period. If f of x gets arbitrarily close to L for all x sufficiently close to x sub naught, we say that f approaches the limit as x approaches x sub naught. And we write the limit as x approaches x sub naught of f of x equals L. Alright, so there's basically the simplest form of a definition of a limit, and we went through this on the previous example where we have some x sub naught and we look up here and we don't care what's happening at x sub naught, but if we approach x sub naught from both sides, and as we approach they come together to some value L over here, then that is our limit.